So on a new sheet of binder paper, let's get some buoyant force notes. So let's draw the three situations we had. The first one is the ping pong ball floating. Second one is the bouncy ball floating. The last one is the golf ball which sank. So whenever you need to, remember, just hit pause. So let's mark on the diagrams the forces. So on all of them, the weight force is the force pushing down, trying to sink them. The weight pushing upward is the buoyant force. Okay, so now let's look, see if they're balanced or unbalanced. So in the first two cases, they're just sitting there, not moving. So that means we have balanced forces. So remember, the first one, the ping pong ball, it kind of looks like maybe the buoyant force pushing up would be more, but if it were, the ping pong ball would be flying up into the sky. So the sunken one, the weight was more, so these are unbalanced forces. The buoyant force pushes upward, and it is the weight of the water displaced by the object. We saw in the demo that an object floats when the weight of the object equals the buoyant force. So an object floats when the weight of the object equals the buoyant force. Another way to say that is when the weight of the object equals the weight of the water displaced by the object. So let's see a couple of examples. I'll give three situations with the same boat trying to float. So here's a water line. In situation number one, the boat is floating high in the water. So just this part of the boat is in the water getting wet. So the weight of the boat pushing down is 20 newtons. Now, the boat is displacing this shape of the water. So this is pushed away. The weight of this displaced water, say I weighed it, it was 20 newtons. So the weight of displaced water equals the buoyant force pushing up, 20 newtons. So since the forces are balanced, it's floating, and this looks like the ping pong ball. Okay, now what do you think would happen if some people came onto this boat? The boat would sink lower in the water. So here's some people on this boat. Now it's pushing away a lot of water. So let's say the boat plus the people, the total weight pushing down now is 50 newtons. This much water is displaced now, way more than in the first case. This amount of water also weighs 50 newtons. The weight of displaced water equals the buoyant force. So 50 newtons is pushing up. balanced. Say you added many more friends on the boat and it was just way too heavy, it would sink. So draw the sunken boat, way too much weight from people. And let's say the amount of people on this boat made the weight be 100 newtons pushing down. Here is why things sink sometimes. So right now, the entire boat shape is underwater. So the water it displaces is the entire boat shape. The weight of this displaced water, say it is 90 newtons, because this much water, that's just how much it weighs. The weight of displaced water is the buoyant force pushing up. So the most buoyant force this boat could ever have is 90 newtons. Unfortunately, the passengers made the weight weigh 100 newtons. Since it's more, it will sink because it's unbalanced. So what happens is an object sinks down in the water until the weight of the water it displaces equals the object's weight. So let's check our pictures again. So when you drop the ping pong ball in or a little boat, it will sort of bob up and down. When it stops because the amount of water it's displacing then is equal to the weight of the boat. If it's a heavier object, it sinks in more because this much water's weight equals the weight of the boat and people. In the last case, the boat, even if it goes fully underwater, the most water it can ever displace weighs 90 newtons. So if the object and the people on it weigh more, then it will sink.